Today we shall discuss about the position of a circle with respect to the axis, x-axis, y-axis and the line. So before going to the position of a circle with respect to the line or our coordinate axis, let us discuss about the basic fundamental definitions, the notations. How do you notate, how do you denote the word circles in a simpler form? Yes, S is equal to hereafter, S is equal to instead of writing a big equation, x square plus y square plus 2zx plus 2fy plus c is equal to 0 in a general form, you can write in a short form S. So therefore hereafter S is equal to 0 means it represents a circle. Now I go for, instead of this, okay, yes. Now what is S1? S1 is nothing but xx1 plus yy1 z into x plus x1 f into y plus y1 plus c. So therefore here you can find out x and y. If I put is equal to 0, it represents a line equation. Next, S11 is represented by x1 square plus y1 square plus 2zx1 plus 2fy1 plus c. So therefore means in the what? In this equation, in place of x and y, you are substituting x1 and y1. Next, S12, yes, come on, x1, x2, y1, y2, plus g into x1 plus x2, plus f into y1 plus y2, plus c. So hereafter, in the sequel, in the what, throughout the what discussion of the what position of a circle with respect to the what, come on, the point with respect to the coordinate axis with respect to the line, whenever, wherever you come across a circle equation, you can write S is equal to 0. If you come across the straight line of the type xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c, aptly you can represent as S1 is equal to 0. Now look here, this is S11. This is nothing but x1 square plus y1 square plus 2zx1 plus 2fy1 plus c. Substituting a point in the what circle equation if it is equal to 0. Now S12. Now x1, x2 plus y1, y2 plus g into x1 plus x2 plus f into y1 plus y2. y1 plus y2. Next, after knowing these notations, we shall make a move to understand the position of a point with respect to a circle. Position of a point with respect to a circle. Let S is equal to x square plus y square plus 2zx plus 2fy plus c is equal to 0 be the equation of a circle. Be the equation of a circle. Equation of circle. Whose center C is equal to minus g comma minus f and radius r is equal to square root of z square plus f square minus c. Z square plus f square minus c. Let P of x1 comma y1 be a point in a plane. Yes, the word plane comes. Now when the plane comes, now I take this is, now I'm going to take this is a circle. This is the interior region of a circle. This is the what? Point on the circle. This is exterior region of the what? Plane. Or this is interior region of a plane. Now this is on the what? Come on, plane. Now outside of the what? Plane. So aptly, circle is a two-dimensional figure. We say it as when the point lies inside, it is this region we call it as interior region. When the point lies on the circle, point lies on the circle. When the point lies outside, we call it as what? Exterior region. What is that? Exterior region. Okay, now let P of x1, y1 be a point in a plane. Now I want to find out now CP square minus R square. Yes, what is CP square? CP is the distance between the center and a point. I am going to select. Say for example, now look here. Now I am going to take this a point P of x1, y1. Yes, this is now the center minus z, minus f. You take another point. This is aptly represented by the radius. So therefore, now I'm going to find out CP square. Apply the distance formula. This becomes x1 plus z whole square. This is y1 plus f whole square minus of z square plus f square minus c. Z square plus f square minus c. So therefore, you expand this. This is nothing but x1 square plus g square plus 2zx plus y1 square plus f square, plus 2fy, or else if you want you can take x1 fy1, yes, minus g square minus f square plus c, we call it as, correct or not? So therefore, now this term and this term get cancels. We are left with x1 square plus y1 square, that is 2gx1 plus 2fy1 plus c. As I told earlier, notations. What is S11? S11 is nothing but what? X1 square plus Y1 square plus 2ZX1 plus 2FY1 plus C. So therefore, I can write nevertheless, this is S11. Hereafter, CP square minus R square is represented with what? S11. Nevertheless, S11 is nothing but a CP square minus R square. Now, let us discuss about the exact position of a point P with respect to the circle. What is that? Now, I am taken case 1 when the point P lies outside the circle. So, therefore, case 1. Now, we have proved here CP square minus R square is equal to S11. So, therefore, now CP square minus R square we have proved as what? S11. So, therefore, now I go for case 1. What is case 1? When P lies outside of the circle, S is equal to 0, means let us take the figure in this way. This is P, this is what? Q, this is C center, this is a radius. You can very well observe here CP. Now look here, CP is greater than what? R, which implies CP square is greater than R square is nothing but what? CP square minus R square is what? Greater than 0, which implies S11 is what? Greater than 0. It means that when the point P lies outside of the circle, S11 greater than 0. Now, next case 2. What is case 2? Case 2 is when P lies on the circle. What is the circle? S is equal to 0. So therefore, let us draw the figure. Now this is center, this is a P, this is also what, come on, Q. Therefore, this is also radius, this is also radius. Now from figure, I can write CP is equal to R. Therefore, CP square is equal to R square. Therefore, CP square minus R square is equal to 0, which implies S11 is equal to 0. S11 is equal to 0. Now look here. When the point lies on the circle, S11 is equal to what? 0. S11 is equal to 0. Now I go to what? Case 3. What is case 3? The case 3 is when P lies inside the circle. Inside the circle, S is equal to 0. Now I go for a what? This figure. Therefore, the C is what? Q. This is C. I take this a P, right? This is a radius. So therefore, you can very well observe from the figure CP is less than R. Therefore, CP square less than R square, which implies CP square minus R square less than 0. Nevertheless, I can write S11 less than 0. Yes, we come across about the position of a point. What is it? Come on. Position of a point with respect to the circle. With respect to the circle. Though when the point lies outside the circle, S11 greater than 0. So therefore, next, when the point lies on the circle, S11 is equal to 0. When the point lies inside the circle, S11 less than 0. So therefore, this is about the what? The position of a point P with respect to the circle in 3 positions. One is inside the what? Circle. One is on the circle. One is exterior to the what? Circle. I mean outside of the circle. Right. After knowing the position, we can call it as what? The another definition, which is quite near to this one, is power of a point. What is power of a point? The power of a point can be defined as, let P be a point in a plane and C be the center and R be the what? Radius of a circle. Then CP square minus R square. CP square minus R square is defined as, CP square minus R square is defined as power of a point. Later, so therefore CP square minus R square is nothing but what? S11. So therefore, so S11 is also defined as the power of a point P of x1 comma y1 with respect to the what? Circle. S is equal to 0. Once again, I am taking this context. Let P be a point in the plane, C be the what? Center, R be the what? Radius of a circle. Then CP square minus R square is defined as a what? Power of a point. But CP square minus R square we have proved as what? S11. So therefore, hereafter the power of a point is also defined as what? S11. Yes. Now we come across 4 definitions. One is power of a point, next exterior, next interior on the circle. After knowing the positions, let us see when the secant line drawn from the point P cuts a circle in 2 points, then what is the power of a point P? Power of a point P. Let us see how to find out that. So the concept is, yes, the secant line through the point P of x1 comma y1 meets the circle in 2 points A and B, then the power of a point P of x1 comma y1 with respect to the circle S is equal to 0 is PA into PB is equal to S11, where PA comma PB are the algebraic distances. Let us see how it is possible. Now, if I go to this one, this is the circle. You draw a what? Line. This is x1 comma y1. This is A, this is B. This is called secant line, right? If it is up to here, it's a chord equation. If it is outside, we call it as what? Secant line. The secant line from the what point P of x1 comma y1 through the point P of x1 comma y1 meets a circle in 2 points A and B, means P is outside. Then now PA into PB is equal to what? S11. What is S11? Power of a point. So therefore, now how to find? This is also another way of finding the what? Power of a point. There are many means. So therefore, now what is this one is? Now let P of x1 comma y1 be a point and equation of the circle be S is equal to x square plus y square plus 2zx plus 2fy plus c is equal to 0. Now, by parametric form or distance form, that is A of x comma y, A or B, right? A or B is equal to x1 plus r cos theta, y1 plus r sin theta. Theta is the inclination of this line. What is r? R is the distance from what? P to A and B. So therefore, I call it as R has two roots, that is R1 and R2. So therefore, what is R1? R1 is nothing but distance from what? P to A. What is R2? Distance from what? P to B. This is. So therefore, now A or B is equal to x comma y is equal to x1 plus r cos theta, y1 plus r sin theta. Therefore, A lies, now since A lies on the circle, what is the circle? S is equal to 0. Lies on the circle, S is equal to 0. In place of x square plus y square plus 2zx plus 2fy plus c is equal to 0. In place of x, you have to substitute. Therefore, x1 plus r cos theta whole square, y1 plus r sin theta whole square. Therefore, 2z into, in place of x, put x1 plus r cos theta. Now 2fy into what? y1 plus r sin theta plus c. Now you expand the equation. What is that? If I expand, look here, this becomes x1 square, here y1 square, right, here 2zx1, fine. Next, here 2fy1, right, 2fy1. Just for simplicity, I am grouping the terms. Next, I go for x1 square gone, y1 square gone. Now here r square into cos square theta plus sin square theta is equal to how much? 1. Next, now look here, you are having here now 2x1 into r cos theta plus 2y1 into r sin theta. Yes, here r square sin square r square cos square, I have taken common 1. Next, now here 2z into r cos theta. Next, 2f into r sin theta is equal to 0, right? Now this is nothing but S11. Now which is a quadratic in what? R square. I can write r square. Yes, come on. 2x1 cos theta plus 2y1 sin theta plus 2z cos theta plus 2f, come on, sin theta into, come on, r plus S11, which is quadratic in what? R square. You call it as equation star. Since equation star is a quadratic in R, and its roots be R1 comma R2. Roots be R1 comma R2. So therefore, now I'll write product of the roots. R1 into R2 is equal to C by A. Therefore, S11 by 1. What is R1? I told already. R1 is nothing but PA. R2 is nothing but PB. So therefore, PA into PB is equal to what? S11. Yes. We could prove as PA into PB, product of the distances is equal to what? S11. What is S11? We proved already, it's a power of a point. The power of a point can also be defined as a what? Product of the what? Algebraic distances. Algebraic distances. Therefore, hereafter, the secant line through the point P of x1 comma y1 meets a circle in A and B, then the power of the point P with respect to circle is defined as PA into PB is equal to what? S11. Yes. Now, so we have a little discussion on this. What is this? Right, circles. So therefore, now what is this one is? When the point P is outside, when the point P is what? On the circle. Yes, when the point P is on the circle. So therefore, when the point P is inside the circle, correct or not? I can say by using the power of a point. Now here, PA into PB is what? Greater than 0. Here, PA into PB is equal to 0. Here, PA into PB is less than 0. Means it depends upon the position of the points. When P is outside, PA into PB is greater than 0. Inside, PA into PB is less than 0. When the point is on the circle, PA into PB is equal to what? 0. Yes, we come across about what? The position of a point P with respect to the what? Circle. With respect to the circle, right? The next concept is the equation of the chord to the circle joining the 2 points A of x1 comma y1 and B of x2 comma y2. So what is that? The equation of chord joining 2 points A of x1 comma y1, B of x2 comma y2 on the circle S is equal to 0 is S1 plus S2 is equal to S12. S1 plus S2 is equal to S12, right? S1 plus S2 is equal to S12. So now, say for example, if I take this what line, this is a line. Now this is A of x1 comma y1. This is B of x2 comma y2, right? Now, the proof of that is very simple, but the application of this theorem you can find very less number of times in the circles, but you get very good examples in the parabola. So if you have the acquaintance with the this theorem in circles itself, so you can do the problems in parabola very easy, especially in objective level. So therefore, what's the proof of this one is very simple. Let S is equal to x square plus y square plus 2zx plus 2fy plus c is equal to 0 be the equation of circle. Let a of x1 comma y1, b of x2 comma y2 be 2 points on the circle S is equal to 0. We know that by using the position of the points, when the point lies on the circle, S11 is equal to 0. So therefore, I can write S11 is equal to 0, and also for this point, we can write S22 is equal to 0. What is S11? x1 square plus y1 square plus 2zx1 plus 2fy1 plus c. What is S22? x2 square plus y2 square plus 2zx2 plus 2fy2 plus c. That is what S11 and S22. Since these 2 points are lying on the circle, therefore S11 is equal to 0 and S22 is equal to what? 0. Now, consider the equation. What's the equation? S11 plus S2, S1 plus S2 is equal to S12. Yes, now let us write what is S11. Now therefore S11 xx1 plus yy1 plus g into x plus x1 f into y plus y1 plus c. Now what is S2? Now x2 square y2 square. So therefore now this is g into x plus x2, come on, so plus f into y plus y2 plus c is equal to S12, that is x1 x2 plus y1 y2 z into x1 plus x2 plus f into y1 plus y2 plus c. You call this as equation 1. Now we can very well observe. So now substitute a of x1 comma y1 in 1. So if I substitute in 1, so therefore this becomes 1 implies x1 square. In place of x and y, you have to substitute x1 y1. Now this is y1 square. Now to this is 2zx1. This is 2fy y1 plus c. You make it 1 in one bracket plus x2 square. Come on, x2 square plus y2 square. So therefore, so xx1. Here there is a little change here. Now this is nothing but xx2 plus is y2. Now therefore this becomes x, that is x2, that is x1 x2. This is y1 y2 plus g into, that is g into x1 plus x2 plus f into y1 plus y2 plus c is equal to, I can write f into y1 plus y2 plus c. You make it as one bracket. This is equal to, you take this one is, what is that? x1 x2 plus y1 y2 plus g into x1 plus x2 f into y1 plus y2 plus c. So therefore, since this is nothing but what? S11. We know it already, S11 is equal to 0. So therefore, 0 plus S12 is equal to S12, which implies S12 is equal to S12. So therefore, one satisfies the point the point A of x1 comma y1. Similarly, one also satisfies B of x2 comma y2. Hence, hereafter the equation of chord joining x1 y1 x2 y2 is defined as s1 plus s2 is equal to what? S12. S1 plus S2 is equal to S12. Right. Now we understood the equation of chord joining A of x1 y1 B of x2 y2 as, that is, S1 plus S2 is equal to S12. Right. Now let us discuss about important topic. One of the important concept is tangent. Now, yes, any line meets a circle in two coincident points. That line is nothing but a tangent. I mean, any line touching the what circle at only one point, we call it as what? Tangent. So therefore, now we can represent through like this. This is the line which meets in two coincident points. So therefore, this is, we take it as x1 comma y1. This line we call it as what? Tangent to the circle. Let us see how to find out the equation of tangent at P of x1 comma y1. So therefore, what is that? The equation of tangent at P of x1 comma y1 to the circle s is equal to 0 is s1 is equal to 0. This s1 is equal to 0 plays a vital role in throughout the coordinate geometry, especially circles, parabola, ellipse and hyperbola. So therefore, s1 is equal to 0 represented tangent. Okay, how is that? Now if I go for this one, is proof of this one is right. Now, so let P of x1 comma y1 be a point on the circle s is equal to 0. So therefore, which implies s111 is equal to 0. What is s11 is equal to 0? x1 square plus y1 square plus 2zx1 plus 2f1 plus c. Right? Whenever you want, you can make use, otherwise not necessary. So therefore, by using the what? Differential calculus, differentiate. What's a circle? Equation of circle B. S is equal to x square plus y square plus 2zx plus 2fy plus c is equal to 0. Now you differentiate. If you differentiate, yes, differentiate 1 with respect to x. Therefore, 2x into 2y into dy by dx plus 2z plus 2f into dy by dx plus 0 is equal to 0. Why? Derivative of a constant is 0. So therefore, you can very well observe 2 is common in all the factors, you can remove that, and here dy by dx is common. So therefore, y plus f into dy by dx is equal to minus of g plus x. Transfer the terms which are not having what? Dy by dx. So therefore, I can write dy by dx is equal to minus of g plus x by y plus f. Now, what is dy by dx? We know it already. The geometrical interpretation of dy by dx is nothing but a slope at a point. Slope at a point means slope of the tangent. So therefore, now I want the slope, that is m is equal to dy by dx at what point? x1 comma y1 is written as z plus x1 by y1 plus f. y1 plus f. This is nothing but slope of a tangent. Slope of tangent. Slope of tangent. Now we can also write slope of a normal. Yes, I am not telling now at present normal, but in the sequel I am going to tell the what equation of normal at x1 comma y1 to the circle s is equal to 0, so that you will be having the familiarity about the what slope of a normal. Now slope of a normal is nothing but, look here, slope of a normal is minus of, yes, minus of minus plus. When the slope of the tangent is m, slope of normal is minus 1 by m. Already minus is there, therefore this becomes y1 plus f by x plus x1 plus g, correct? x1 plus g. So therefore this is the slope of the normal. At present I do not want this. Okay, I want to go for this one is. So therefore equation of tangent at p of x1 comma y1 to the circle s is equal to 0 is y minus y1 is equal to m into x minus x1. y minus y1 is equal to m into x minus x1. So therefore y minus y1, yes, minus of what do you have, z plus x1 by f plus y1 into what, x minus x1. Cross multiply, this becomes y minus y1 into f plus y1. Now this is equal to, that is plus g plus x1 into what, x minus x1 is equal to what, 0. So therefore after simplification, fy minus fy1, next yy1 minus y1 square, next gx, this is gx1 minus gx1 minus x1 square is equal to 0. Transfer the terms which are having a what, minus signs to RHS, it can become positive signs. So therefore now coming to, yes, now what is that, y1 minus y1 f plus, that is f plus y1. So therefore this is what, okay, cross multiply, this becomes x1 square. What is that, come on, x1 square xx1. So xx1, here something is missing, x minus of x and x1 square xx1, zx minus gx1 minus gx1, next minus gx1, next this becomes xx1 plus xx1 minus x1 square is equal to 0. Now I am going to write xx1 plus yy1 plus gx plus fy is equal to x1 square plus y1 square, yes, come on, plus gx1 plus fy1. Okay, so therefore now we have a less number of terms. Whenever you want the what, less number of terms to what, get more number of terms, you have to add and subtract or divide and multiply. At present add and subtract. So therefore what, add and subtract gx1 plus fy1 plus c on both sides, add and subtract. So therefore xx1 plus yy1, therefore gx plus fy. Now gx1 fy1 plus c, adding on both sides, this becomes x1 square plus y1 square. Now gx1 2gx1, now fy1 2fy1 plus c. So therefore this is nothing but xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c. This is nothing but s11. So therefore this is nothing but s11, this is equal to 0. Since I told s11 is equal to 0, point lies on the circle, therefore s11 is equal to 0. So therefore now hereafter, what's the equation of tangent at the point p of x1 comma y1 to the circle, s1 is equal to 0. What is s1 is equal to 0? xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0 represents the equation of a circle, represents the equation of tangent to the circle. At what point at the point P of x1 comma y1. Yes, this is the stage when there is a tangent, there must be a normal. What's a normal? A line perpendicular to the tangent at that point P of x1 comma y1. Let us discuss what's the equation of normal at P of x1 comma y1. Now let us discuss the equation of normal to the circle at a point P of x1 comma y1. So therefore, what I told, what's a normal? This is the what? Tangent at the point P of x1 comma y1. Any line perpendicular to it is not, any line perpendicular to the tangent is called what? Normal. Yes, the equation of normal to the circle s is equal to 0 at P of x1 comma y1. Now we have to find out this. We know that duplicative. We know that equation of tangent at P of x1 comma y1. P of x1 comma y1 is xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. So therefore, I can write this one as now xx1 plus, that is g x plus x1 into z plus y1 plus f into y, and remaining is gx1 plus fy1 plus c is equal to 0. You call it as 1. As I told, now normal is a line perpendicular to the tangent. Now equation of line perpendicular to 1 is, it is y1 plus f into x minus x1 plus g into what? Y plus k is equal to 0. Now how to find out k? Remember, for a circle, the normal always passes through the center of a circle. This is minus g comma minus f. Okay, minus g comma minus f. So therefore, now since 2 is passing through the center, minus g comma minus f. Therefore 2 implies minus g into y1 plus f. Next, minus f into, that is x1 plus g plus k is equal to 0. Therefore k is equal to g into y1 plus f plus minus f minus f into x1 plus g. So therefore, now 2 implies, what 2 implies? That is y1 plus f into x. Yes, now minus x1 plus g into y. You substitute this. This becomes g into y1 plus f minus f into x1 plus g is equal to 0. So therefore, now you can very well observe. So x1 plus g, you take the common factor. Now this is after simplification. This is nothing but what? The equation of what? Normal. Equation of normal. So therefore, you can very well observe this always passes through the what? The center of a circle. Passes through the center of a circle. So hence, so this is nothing but equation of a normal. What we understood is that is normal always passes through the center of a circle. Center of a circle. Right. Next, we shall understand the position of a line the position of a line with respect to the circle. S is equal to 0. Now position of a line, position of a line, position of a line with respect to a circle, right? Now when the line cuts the circle in 2 points, when the line you take this line L is equal to 0, you take this S is equal to 0. When the line cuts a circle in 2 points, then it is a chord. Then now the line L is equal to 0 is a chord which cuts in 2 points. Now if we take a circle, when a line L touches the circle in only 1 point, then it is a tangent. So therefore the line L is equal to 0 is a tangent to the circle. Next, when the line when the line like this neither touches nor intersects the circle. So therefore these are the positions. When it cuts in 2 points, then it is a chord. When it touches at 1 point, then it is a tangent. Now this is neither touches nor intersects. Then what is the relevant condition, mathematical condition, when a line cuts a circle, when a line touches a circle, when a line neither touches nor intersects a circle? You must have a mathematical representation or a condition for all the three cases, right? Okay, now coming to, let S is equal to 0 be the circle and L is equal to 0 be the line. So be the line. D is equal to perpendicular distance from the center of the circle S is equal to 0, and R is equal to radius of the circle. Let us discuss the mathematical condition for a line. So according to what? Cutting in 2 points, touching at 1 point, neither touches nor intersects. What is that? Now this is a circle, right? Now this is a center. Now this is nothing but a radius. Now this is the line, cuts a circle in 2 points. This is nothing but distance. This is D. D is the perpendicular distance from the center to the line. This is radius. Now this is nothing but now you can go for this one is, now this is another line, you can go for this, but here up to here it's a radius, correct? Up to here it's a radius. Now when the line cuts a circle in 2 points, we can say R is greater than D. Because up to here it is R, up to here it's R, but here it is D. What is D? Perpendicular distance. When the line cuts a circle in 2 points, so therefore roots are real and distinct, therefore R greater than D. Next, when the line touches the circle, now the roots are real and equal, so therefore R is equal to D. When the line neither touches nor intersects, you can go for up to here, correct or not? This is R less than D. Yes, now we came to know that the position of a line with respect to the circle. When the line cuts a circle in 2 points, R greater than D. When the line touches a circle in 1 point, R is equal to D. When the line neither touches nor intersects or less than D. This is the position of a line with respect to the what? Circle. With respect to the circle. With respect to the circle. Understood? So therefore, now, so let S is equal to 0 be the circle, L is equal to be the line, and D is equal to what? Perpendicular distance from the center of the circle. S is equal to 0, and R be the what? Radius of the circle, according to the condition. So therefore, now when it cuts in 2 points, R greater than D, when it touches, R is equal to D, when the line neither touches nor intersects, R less than D. To know the what? The nature of a line and a circle, I have made what? One word, I have used one word, R greater than D. I told roots are real and distinct. Why? Yes, wait for a minute, I tell. Here I told roots are real and equal. I told roots are what? Imaginary. To know the nature of a circle and a line, what you have to do depends upon the given equation of a circle and a given equation of a line. Convert them either quadratic in x or quadratic in y by solving them. So if you convert them as a quadratic in x, yes. So therefore, when the line cuts in what? 2 points, roots are real and distinct. When the line touches, roots are what? Real and equal. When the line neither touches nor intersects, the roots of that concerned or what? Respective quadratic equation will be what? Imaginary. Will be imaginary. Okay, in the what? Next class, we shall understand what is the nature of a line and a what? Circle.